Okay, question number one. A rock falls into a well and strikes the water 2.3 seconds later. How deep is the well? So you have a well, a certain amount of depth. The rock just falls straight down. It says this takes 2.3 seconds. And they want to know what the Y final is equal to, right? Y final, which is right here. We want to know how far down below it is. So we're going to call position initial is equal to 0. We're going to call that the top of the well. So this should be a negative number because it's going to fall a negative distance. So what do we know right off the bat? Let me shrink this out of the way here. I see the drawing. Okay, I don't need that anymore. So we have the acceleration is equal to negative 9.8 meters per second squared. Our position final, well, we don't know what that is. Our position initial is equal to 0, and our velocity initial is equal to 0. I don't know what our velocity final is. I don't think it's important that we even write that, because right off the bat I can tell that we're going to use a cliff formula, because when something falls down the well, you can usually use a cliff formula. So y is equal to 1/2 at squared. Now this is y final, the way it usually ends up. Do we know these things? Yep, we know acceleration. We know the time. We just don't know what y final is, the final position of the rock. We don't know where it's going to land, how deep in the well it's going to land. So let's just fill these in. So 1/2 times negative 9.8 meters per second squared times 2.3 seconds squared. Now we're squaring 2.3 seconds, so I'm going to kind of do that separately here. So is equal to 1/2 negative 9.8 meters per second squared times, that's 5.29 seconds squared. Okay, the reason I did that, now you can see seconds will cancel with seconds, and we're just left with meters, which is equal to 25.9 meters. So this is your answer. The well is 25.9 meters deep. Question number 2. A bird drops dead while flying at an altitude of 43 meters. So we have, let's call it y initial is equal to 0. Y final is equal to negative 43 meters. Why do I arrange it this way? Why don't I take it as the bird's at 43 meters and falls down to 0? If we do it that way, technically we can't use the cliff formula, because then you have a position initial. Remember, we got rid of the position initial just through some fancy mathematics. So you can use y final is equal to 1/2 at squared. Okay, we can use this formula assuming y initial is 0. So that's why we take y initial 0 and y final to be negative 43. So, a picture of this is, here's a bird. This bird drops dead, falls to the ground, and it falls negative 43 meters. This is 0 meters, and that's all we know about it. Well, we know acceleration is negative 9.8 meters per second squared. So here's our drawing. We can already tell that we can use the cliff formula. Do we know its final position? Yes. Do we know its acceleration? Yes. Can we determine the time? Yes, we can. So let me get rid of this real quick. Let's move that out of the way. So again, I'm going to rewrite this. Y final is equal to negative 43 meters. Velocity initial, how fast was it going? The bird was just sitting there, hovering, let's say, so its speed was 0 meters per second. It's just sitting there. It falls out of the sky. That's why I put drops dead, and all of a sudden it falls. If you haven't gotten that, make sure that you understand this bird is just basically hanging out there and falls down dead. Don't worry that it was moving like side to side, as long as it wasn't going up and down. Y final is equal to 1/2 AT squared. Now, if you already looked at how these things are arranged, you should have this formula already rearranged for you. So it's going to be 2y final over a square root is equal to t. See how nicely I did that? That's because I've had a lot of practice, and you should practice too. So let's just rewrite this as 2 times negative 43 meters over negative 9.8 meters per second squared. Where a lot of people run into problems, they don't keep the negative here and the negative here. It's nice that those two are negative. That way you don't have a unusable radical. You can't have a negative number under the square root sign, otherwise you won't be able to find the answer. So a lot of times all you have to do is make sure that your 9.8 is negative, and make sure that the object is falling downward. You're going to get a negative number. So we have is equal to the square root of 8.78 seconds squared. When we take the square root of that, we get 2.96 seconds. Again, some difficult assumptions is, we're going to take this initial position as 0. We're going to take the final position as negative 43. Your initial velocity, the bird was sitting still when it fell out of the sky. I know that sounds strange, but that's the way it goes with this one. It was hovering there. So its initial velocity was 0. You can use a Cliff formula. As long as the initial velocity going up or down was 0, you can use the Cliff formula. Okay. Problem number 3. You have a person on a building. They're washing the windows. The person's squeegee falls down. This distance is, let's say, 0 meters, and it lands up at negative 15 meters. We'll call this is equal to position initial. This 15 is position final. The acceleration is going to be negative 9.8 meters per second squared, and they're looking for velocity final. Big question mark. How about, do you know the velocity initial? How fast was it going when it fell out of the girl's hand? Well, it just fell out of her hand, so we're going to say velocity initial is 0. So this is our picture, kind of with our variables drawn there. Let's shrink this up here. Okay, it's not shrinking. Come on, shrink. Okay, just go away. Yeah, I just slid that out of the way, sorry. So what do we know? We know our y final is equal to negative 15 meters. Our acceleration is equal to negative 9.8 meters per second squared. Our velocity initial is equal to 0 meters per second. What was our initial position? What was it? We chose that to be 0 meters. And again, we want to know velocity final. We don't know that. So let's look at our formulas. The formula that comes to mind is the last formula on page 88. We have velocity final squared is equal to velocity initial squared plus 2a delta y. Let's make sure we know all this stuff. Do we know velocity initial? Yes, it's actually 0. Do we know acceleration? Do we know its change in position? Yeah, it went down negative 15 meters, so that's the delta y. So we can use this formula very easily. So velocity final squared is equal to 2 times negative 9.8 meters per second squared times negative 15 meters is equal to, let's see, the meters here. This meter is going to go with this meters here, so it's going to become meters squared. Okay, so we have meters squared over second squared. Just watch what happens here. We're going to land up with velocity final squared is equal to 294 meters squared over seconds squared. Now, don't forget, we have the square here. Now, I'm not asking you what the answer is in terms of its square. I want velocity final without that square up there. So to get rid of it, what we've got to do is we've got to take the square root of both sides. And what's going to happen, that's going to get rid of this one here. So what we land up with is velocity final is equal to the square root of 294 m squared over second squared. And that is equal to 17.1 meters per second. So notice how these, when I took the square root, that I took the square root, this square disappeared and this square disappeared, and we landed up with meters per second, and that's what velocity final is. So there's our answer. A little bit of a hint for problem number 4. The answer is going to be 132 meters. For problem number 5, it's going to be 3.9 seconds. And for problem number 6, it's going to be, the answer is going to be 25.8 meters per second. Now the trick that I threw in, I gave you the height of the cliff in feet. You got to get rid of feet and change it into meters. And to solve this, 3.28 foot or feet is equal to 1 meter. So make sure you convert that 34-foot cliff, make sure you convert that into meters right away. Again, get rid of your improper units right off the bat.